Hello people, welcome one and all to Jojo's Learning Club.
Hello guys, welcome back to my channel Jojo's Learning Club. So today I'll be discussing on errors and approximation. So today I'll introduce you to the common errors which we make during calculations. The first error I would be discussing would be on errors due to measurement. So these errors are made when you deal with problems with measurement quantities such as mass, time, distance or any other such quantities. The exact answer you can't give. An answer with the stated degree of accuracy could be given. And when these type of errors occur, these type of errors are known as the errors due to measurement. So to limit the errors due to measurement, the final answer is written with not more than one significant figure greater than the least accurate number in the data. So this I could explain you better through the example A with the area of triangle. Okay, so the next error is rounding of error. Let's take the example with pi. So I have written the equation for pi, or the value for pi. Pi's value is 3.1415965. Yeah, by seeing this value you know that it is a non-terminating decimal fraction. So you can see that rounding of errors are mostly occurred on decimal fractions. When you have a non-terminating decimal, you have to write in terms of some significant figures so that you can round it off. So I'm going to write it up to 4 significant figures. So I'm going to round it off. So 3.14. Yeah, while rounding off, you have to be careful, you have to check. So I am rounding it up to 4 significant figures, that is 3.141. The last digit after the last digit of the significant figure, you have to check. After that, if it is a 5 or if it is in the group 0 to 4, you don't make any change for the last significant figure. But if the value is between 5 to 9, then you add 1 to the last number of the significant figure. So you can round it off and write it as 3.142, and hence you have made an error, rounding of error. So this is what meant by rounding of errors. So next would be blunder. Blunder is an inappropriate procedure used to calculate a wrong answer. So this is what meant by blunder is. Okay, and the next topic would be on order of magnitude errors. When you place a decimal point inappropriately in an answer after the calculation, these kind of errors are known as the order of magnitude errors. So to reduce the errors due to order of magnitude and blunder, we can easily do some method. You can use the form of approximation. So as an engineer or as a technician or as a production manager, it is always sure that you will be coming across some calculation problems and you should be very quick with these calculations. For that, we use the technique of approximations. So let's write an example. So here an example is given, right? So it is very tough when you try to do it using calculator to find the exact value. Now we can approximate that so that you find a value somewhere near to this value. So 49.1, I am going to round it off as 50 so that it is in round off numbers. So it is very easy to calculate. 18.5, I round it as 20. 122.1, I round it to the nearest tens value 120. And 61.2, I round it as 60. And 38.1, I round it as 40. So 60 goes here 2 times. 20 into 2 is 40. So the final answer is 50. So we got the answer 50 as an approximate value. Now we know that the value would be somewhere between 45 to 55, right? But we also know that it won't be anyway 5. So we can avoid blunder from it. Or you also know that it won't be 500. So by this, we can be sure that we have not made any blunder or order of magnitude errors. The actual answer by using a calculator, it was 47.31. So by doing approximation, you can avoid errors due to blunder and order of magnitude errors. So that's all about errors and approximation. Let's do some problems using errors and approximation so you can get better understanding. So my first problem would be the area of a triangle is A is equal to half BH. The base B when measured is found as 3.26. So when measured, the base is 3.26 centimeter And what is the next step? The height is also given, right? Height is given as 7.5 centimeter. Okay, so now I'm going to make an approximate value for it. So A is equal to half BH. So half into 3.26 into 7.5. Yeah, so while doing approximation, as I said, you can round off numbers. So I'm rounding it to 3 because it is less than 3.5 and 7.5. So I'm going to write it as 8. So the value approximately would be 12 centimeters. So it should be somewhere near around 12. And let's do it by calculator too. So while by doing with calculator, I got the answer as 12.225 centimeters square. So here it is also centimeter square. So the actual answer is 12.225 centimeters square. So while doing errors due to measurement, so we have to consider the errors due to measurement too. So as by the rule, it is said that the final answer is not more than one significant figure greater than the least accurate number in the data. So this is a measurement problem, and here the least accurate measurement is on 7.5, and this is having only two significant figures, right? And here you have three significant figures. So the value of our answer should not be greater than three significant figures. That is what meant by this. So 12.2 centimeters square is your final answer. I hope you understood how you should deal with measurement problems now. So that's all for the errors due to measurement. And next, let's do some 4 more problems for your better understanding on other kinds of errors. State the type of error made in the below problem. So 72 into 31.249, which is given as 2262.9. Can you please check it the answer using a calculator? You would get the answer would be 22.62.88 something. So what you have done here, you have rounded it to 5 significant figures. So the answer for this problem would be rounding of error. So the error which occurred here is the rounding of error. So because the value is only 9 here, the actual answer is 888 and it's a non-terminating. So sorry, it is a terminating decimal, but you have more fraction after the decimal point. So more numbers after the decimal point, but you round it to one decimal point, one number after the decimal point, and that's why you name it as the rounding of error. Now let's take the next problem, B. Okay, so 16 into, we have to check whether these is the value same. 16 into 0.808, I can write it as 8 by 100, right? Into 7. So now you can write 4 times, so 4, 25. So 32 into 7 by 25, which is nothing but 224 by 25. And this is a improper fraction. When you have an improper fraction, you have to write in terms of mixed number. So let's write in terms of mixed number. Then the answer would be 8 would be 425, and which is nothing but 8.96. 8.96. What is the answer here? 89.6. So this is the wrong answer. And what kind of error it would be? It is a blunder, because you use inappropriate procedure to find the final answer and you have found a wrong answer. So the error due to this is blunder. And now let's check what is the value of this. Okay, so sorry, this is not a blunder. This would be order of magnitude error. As you have placed, the answer is correct, but the decimal points placed are inappropriate, and the errors formed due to this is the order of magnitude error. So this is an order of magnitude error. And now let's take another example, 11.714 into 0.0088. So let's find example for this. So 11.74, I approximate it as 12, and this is, I take 0.0008, which can be approximated as 88, right? So I'm approximating it into 0.009. So 0.09 is 9 into 10 raised to minus 3. So you write it as 9 into 10 raised to minus 3. 12 into 9 is 108 into 10 raised to minus 3, which is nothing but 0.108. So value should be somewhere in range 0.108. And what is the value you got here? It's a value here represented as 0.3247, which is something entirely different from the value from the approximation. So you can now state what kind of error it would be. I've already written in the first step, it was blunder, because you used an inappropriate procedure to find the wrong answer for a calculation. And these kind of errors are known as blunder. So the next problem would be 29.74 into 0.0512 by 11.89. So let's do again the approximation, right? So 29.74 I'm going to approximate as 30, and here I'm going to approximate it as 0.6 by 12. So let's write it. I am going to cut it down, and I'm going to write it as 2. So it is 30. 30 goes 2, and here I'm going to write it as 5. So you know that it is 0. This is a approximate value. So now you can be sure that there is no blunder or order of magnitude error in this problem. But again, the final answer is somewhere in the range 0.128, and there are other decimal fractions or other numbers after these two numbers. So it's not the final answer. 0.12 is somewhat rounded off. And what kind of error it would be then? It is a rounding off error. So this is what all about errors and approximation. You have to be always careful while doing calculations using calculations. You have to always check what kind of errors and approximations you should make. So when you have a measurement quantity, you should always check that the final answer is limited, which is having one significant figure greater than the least accurate number in the data. In the above problem, the 7.5 was a least accurate number. So the final answer should not have, here you have only 2 significant figures. The final answer should not have more than 3 significant figures. And this is how we limit the answer while taking in account of errors due to measurement. And the next one is rounding of errors, where you round off to some numbers, and the errors found due to this is rounding of errors. What is a blunder? When you use an inappropriate procedure to find the answer for a wrong calculation, you can say it as a blunder. What is the order of magnitude error? When you place the decimal points inappropriately after the calculation, these kind of errors are known as order of magnitude errors. So that's all for this section, and my next section would be on conversion tables and charts. So let's see you over there. Bye.